Hello, everyone. Welcome to the TDWI webinar program. I'm Jim Powell, Editorial Director at TDWI, and I'll be your moderator. For today's program, we're going to talk about empowering your data science with data enrichment. Our sponsors are Ironside Group and Precisely. For our presentations today, we'll first hear from Fern Halper with TDWI. After Fern speaks, we have a roundtable discussion with Pam Askar from the Ironside Group and Mike Ashmore from Precisely. But before I turn over the time to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask Question area there on your screen to type it in and send it to us. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive technical assistance. If you'd like to discuss the webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. Finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we are recording today's event, and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or share it with a colleague. Okay, again, today we're going to be talking about empowering your data science with data enrichment. At this time, I'd like to introduce Fern Halper, Ph.D., TDWI Vice President and Senior Director of TDWI Research for Advanced Analytics. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology during the last 20 years. Fern is also co-author of several dummies books on cloud computing, the hybrid cloud, and big data. At TDWI, she focuses on advanced analytics, including predictive analytics, social media analysis, text analytics, cloud computing, and big data analytics approaches. She has been a partner at industry analyst firm Hurwitz & Associates and a lead analyst for Bell Labs. Her Ph.D. is from Texas A&M University. Fern, I'll turn things over to you now.
Great. Thanks, Jim. Hi, everyone, and thanks for joining us today on this webinar on the important topic of data enrichment. We know that you're busy, and we appreciate you taking the time out to be with us. So here's what we're going to do. I'm going to kick things off. I'll speak for about 5 minutes about trends for utilizing diverse data in data science. So basically what we're seeing at TDWI in the way of diverse data, and I'll define data enrichment for you. Then Pam from Ironside will introduce herself. I'll hand it over to her to introduce herself, and she'll tell you a little bit about Ironside, and then ditto for Mike from Precisely. And then we'll move into the roundtable discussion, which is going to be the bulk of the hour, about 30 to 35 minutes there. And we'll save the last 10 minutes for Q&A, so make sure to put your Q&A in the Q&A box that you see. Okay, so in terms of trends, what we're seeing is that organizations are starting to manage a lot of diverse data, especially for analytics. So if you take a look at this chart actually comes from some research we did at the beginning of 2021 about data and analytics. And in it, we asked, what kind of data is your organization managing now or looking to manage in the next year? And in this chart, the green is managing now, and the purple is looking to manage in the next year. So of course you could see, big green bars for structured data and transactional data and even demographic data. And we typically see, organizations bringing together their structured data and demographic data to try to do analysis. But if you look at the box that I drew there, which is that red box, you can see that there are other kinds of data that organizations are interested in as well. So they're already collecting things like internal text data. They're collecting semi-structured data. They're collecting geospatial data and external text data. So there you see that there's anywhere between 25 to 35% of the respondents to this question were already collecting this type of data. And if you look at the purple bar, that number is expected to increase over the next year. Now, whether it increases that much, of course, users sometimes stick to their plans. They sometimes don't. But, there's definitely interest and growing interest in collecting this kind of data. And the question is, why are they interested in that? They're interested in this type of data because it really helps to enrich their analysis. So this kind of data can really help to enrich your analysis, and we'll talk more about this. You can also see, that there's other kinds of data, like machine data is also looking to be a popular type of data as well. So data enrichment is the process of combining company data with diverse data from other systems or third-party sources. So that data from a third-party source could be weather data or industry-specific data. It could be geospatial data. And at TDWI, we see that organizations are using their internal data, like ERP data and CRM data, and then marrying that together, as I was mentioning before, with their demographic data for analysis. But as they move to data science, they also want to use more diverse type of data, and they often make use of things like weather data and image data and geospatial data and, other types of data sources, text data, that they'll extract sentiments and entities, and they'll try to marry that together with the structured data that they have to get to the why behind the what. So data enrichment is becoming very popular. So, here's my very simple example. We'll dive into this in a little bit more detail and show you what geospatial data could actually look like and how it's used later on in the presentation. But this is my simple example of how organizations might make use of geospatial data. So let's say you're some sort of retail company and you want to understand your customers better. And so you're collecting data about them. You might have the average monthly billed amount, you could see here for certain customer IDs, and the length of time someone's a customer. And you could see that if you just look at these two columns, there isn't necessarily a pattern in the data. It's not like someone who's been a customer for a longer amount of time is spending more money with you on average, for example. But if you start to bring in other forms of data, if you enrich your data, and in this case, I just have the simple example of location, the actual city, you could see that those cities that are in the Northeast, customers who are in the Northeast are spending more money than those that aren't in the Northeast. And then, you would bring your data, other data together with this to try to dig more deeply into this. So the point is that diverse attributes are useful in data science. So that's my quick introduction. So with that, I want to turn it over to Pam. We're going to start our roundtable discussion. So Pam Askar, Ph.D., is the Director of Advanced Analytics at Ironside Group. And Pam, why don't you introduce yourself to everyone?
Great, thank you. Hi, everyone. As Fern said, I'm Pam Askar. I'm lead our Advanced Analytics practice at Ironside. And Ironside is a Boston-based analytics AI and cloud firm. I've been there for about 6 years now, but I've been delivering advanced analytics solutions across industries for over 10 years. And I've spent a lot of time primarily with organizations that are very immature with AI, that are looking to get started, and taken them from what is AI, how would we even use it, all the way through having deployed solutions, having their own machine learning tech stack, having their own data science team, right? And that's a long-term process to get there. But we've worked with a lot of these organizations, bringing them through that path. And simultaneously, we've also worked with a lot of organizations that struggle with that path, that may not, financially be in the position to acquire all that machine learning technology, to bring in a data science team to support after the consultants leave, that really aren't quite even bought in. Like, do we have enough data? Do we have the right data? And is AI going to work for us before taking that leap into all these capital expenses? And so, in addition to the primary way that we've worked with clients, we have also started to offer a data science as a service approach. And I want to bring this up now because it's actually turned out to be such a fantastic vehicle for data enrichment as well. And the idea with data science as a service is that instead of starting the conversation with what technology do you want to evaluate and consider bringing in, we start with the use case. What are your business problems? And we provide the technology, and we provide the resources, and we can manage that all the way through deployment and production and monitoring long-term and watching for accuracy drift. And so it takes all those barriers out of the way. So we can start with, what are your business problems? What are the right use cases? And let's start evaluating those. We can bring the data into this tech stack and perform what we call a rapid viability assessment. It's an RVA. And in that, what we're doing is profiling the data. Do you have the quality and the quantity that you need? And that's where we can start having conversations about what external data might also be available to supplement it. And if a use case at the end of that rapid viability assessment appears to be viable, there's some signal in there, there's some good data, we can move on to machine learning, right, and actually train the algorithms. Then we can move on to deployment, and then we can move on to watching it and tracking it long term. So like I said, this is such a great vehicle for organizations to get started evaluating whether AI is right for them, whether it's going to bring them value, get started evaluating what third-party data could be brought in to enrich theirs to make those the advanced analytics models more accurate, right? All without interfering with their own infrastructure, right? All without pausing to do technology evaluations and installs and configurations, all without capital expense, right? Because this is all pay as you go. So it allows organizations to kind of take step by step. So I wanted to bring this up because I think a lot of what we're going to talk about today, I can bring back to Ascend AI, our data science as a service offering, and explain how that can really help it. And Precisely has been such a great partner in this, and we've had some great successes. So let me pause there and turn it over to Mike to introduce himself. Happy to be here today with Mike.
Hello, everyone. Thanks, Pam. My name is Mike Ashmore, and I work in the location intelligence business within Precisely. I'm the product lead and SME, that's subject matter expert for everything geocoding, addressing, address validation, and enrichment. And with Precisely, you may not have heard of us before because we're a relatively new brand, but you will absolutely have been touched by the products that I lead and many of the other products in our portfolio. We sell our addressing technologies to the majority of the insurance companies in the United States and insurance companies across the world. Anyone that's ever had a mortgage in the US will have been impacted by us, whether that be from a flood determination perspective or the two organizations that are the largest that buy mortgages use our technologies. The largest credit card companies, they use our technologies. If you use social media platforms, you will ever notice how they know what your where you live and what the name of your neighborhood is. That's our data that's sat behind there. So we touch a lot of people's lives and a lot of different customers, and we do this all by focusing on data and the data integrity. And the way we define data integrity is that it's about integrating technology, data together in various different technologies. We're talking about then data quality, so the fixing of that, making sure that it's accurate and consistent. We then focus a lot of that data on the location intelligence topics, which is somewhat unique in the data business, to be able to understand location data. And many people ask me, what is the difference between location data and other data? And I ask them to imagine storing their data in a spreadsheet, as most of us do on a regular basis. And the big difference between location data and regular data is that squiggly lines don't go very well into spreadsheets. And that's essentially how you could imagine location data, because we're dealing with man-made and natural objects that are, quite frankly, map-related, squiggly lines, roads and rivers and boundaries. The final part of our business is really about data enrichment. So we are focused around those technologies to achieve the outcome of enriching data that Fern gave such a beautiful description of earlier. And with that, I think we're back, we're on to some questions.
Yes, I want to get started. All right, so I gave a bit of an overview about why external data is important and what we see at TDWI in the way of external data. And of course, this data can be structured data, can be unstructured data, can be semi-structured data comes in all different shapes and sizes. So Pam, I'll go to you first. In your practice, why are you looking at external data? Why are you looking to bring it in? Why is it important? Oh, and full disclosure here that our panelists have seen the questions beforehand, so you'll see some slides that they provided us to help better articulate their answers. So Pam, to you first, why do you look to bring in external data?
Yeah, I like this question. It's a great place to start because before talking about all the value, just why do we even consider this, right? Why are we looking for it when we're doing machine learning? And I have this little demonstration to walk you through to talk about it. If you think of this icon as a flat file, right, structured data, your rows there are observations, their clients, their transactions, their claims, whatever they are. And, our clients will often say things like, we don't have big data, so we probably can't do AI yet, or we're a few years away from that. And the reality is when people are thinking about, do they have enough data? They're thinking about those rows and thinking they need millions and billions of those. And the reality is there's diminishing returns on that, right? And you'd be surprised at sometimes how little data you need. You need enough examples. You need enough observations of the same kind of thing happening over and over again. But once you get to that point, more and more observations don't teach a machine learning algorithm anything more than that, right? And so if 100,000 rows, just pulling a number out of the hat there, if 100,000 observations is enough to build a good machine learning model, then adding 1 million or 2 million or 10 million doesn't make the model that much more accurate, right? Maybe you get incremental gain, but not that much. And so really when I look at a client's data, I want to make sure there's that minimum, do we have enough observations? But really where we want to get some boost, especially after building a baseline model, where you want to make that more accurate and get some boost is from this other dimension of data. It's having more data elements. So if you think about the columns as attributes of your claims or your customers or your transactions, right? It's things about them. It's their history. It's their behaviors. It's the products they've purchased in the past. Kind of like the example that Fern had shown, right? It's the attributes. And you're hoping these attributes are correlated with some outcome. Adding more of these actually gives a machine learning model more information, right? It's like teaching a child something. You give them more books or more information on a topic, they're going to learn more, and an algorithm's the same way. So sometimes our clients, their data can be very transactional with their clients, right? And it can explain historical patterns, and you can use that to build a good machine learning algorithm. But there's a lot of external data out there that helps you understand what's driving those patterns, what might lead to changes in those patterns so that you can anticipate them, so that you can be ready to offer your clients the products they need right now today. And so that's where we get the biggest boost in model performance. Right. Sometimes we will go through a client's database and build a solid model and it's 78% accurate or 89 or whatever. If you want more than that, that's where we say, let's bring in some external data, because that's really the best way to get it. It's not adding more and more and more clients. It's adding new information about those clients. So.
And do you sometimes think of that as being data that they may not have thought of to use before, even if it's internal to their company? I mean, there's the external data and then like maybe some data that's internal to their company that, can help to enrich it also. Yeah,
absolutely. We go through a whole brainstorm process because that's really part of the data science team to go in there and extract what we can and use it in very creative ways.
Yeah, Mike, did you have anything you wanted to add to this first question about, why? Why look at external data?
Well, I mean, external data is often providing the information that you don't get from the internal. It's not just it's providing the context that cannot be seen through the internal lens, and that's what the value of external data is, providing that.
Yeah, it makes sense. So, let's go on to this next question. And Michael, I'm going to stick with you on this one first. We know that data enrichment is important. I mean, I was saying to Pam just before, it could be data that you haven't thought about, but, any sort of type of data that's going to provide more attributes. Like I always think about, and this is probably just because the type of analysis I used to do at AT&T in terms of churn analysis, and I'd be looking at, customers that were going to churn, and I'd want to bring in, internal text data from trouble tickets, and then extract information out of those trouble tickets to be able to marry that together, with other data to get to the why. What kind of data do you think is useful for enrichment? And can you give us some examples? You were talking about geospatial data. Maybe you can drill more into that.
Yes. I mean, look, I don't want to make it exclusively about our portfolio of enrichment data, because most of the clients that we jointly work with are bringing in not just our data, but also other people's reference data. But what we focus on, as we sort of said, is the geospatial side of data to deliver that why. And we've got a pretty large portfolio of that we deliver to, some of those clients I was talking about, and including your former employer. And the focus can be broken into these buckets. So we've got a lot of addressing and property-centric data, so that we know about what's going on at an individual address. So when we're talking to insurers and telco companies that are trying to figure out about an address and to be able to understand the opportunity or the risks associated with it is pretty important. Then we look at boundary-based data. So this is usually man-made and artificial and natural boundaries, like country boundaries and county boundaries and geographic boundaries, which is very useful for rounding things up and doing analysis by those boundaries, because while they might be artificial frequently, the administrative nature of them serves a good purpose for aggregating data up. We also have a great focus on demographics, and we know that that's so insightful for anyone doing any kind of marketing activity. When it's to do with consumers, demographics describes the people, whether it be about how wealthy they are, how much they spend, the types of life stage that they are at. So important to understand that from an opportunity or a service delivery perspective. Another area of focus is our points of interest. So for clients that are dealing with a business-to-business scenario, so they care about where other businesses are, where money is getting spent and the types of money that's getting spent, we provide that. And then the final area that we focus on is like mapping data, if you will, so for visualization of results. And when we look at our portfolio, if I were to take any single address in the US, for instance, we've got somewhere in the region of 9,300 individual attributes that we could append to a single address. So it's very descriptive depending upon the business need. And as I say, while that's our data portfolio, and we focus on a couple of key areas within that, we frequently find that many of our clients will go outside of our portfolio and go and get yet even more data that's very specific to their business needs.
Yeah, that all makes sense. I didn't realize that you did points of interest and, that there's 9,000 different attributes that you could append. What's an example of one of those 9,000?
Well, let's pick on that one that you just suggested, points of interest. We can tell you the type of business that it is as defined by either an NAIC code, which is the US coding structure, or the international coding structure, the SIC code. So we know in detail about a business, or the number of employees, or what its fascia would be. If we looked at addresses, we would know, the mortgage company that's providing that, and the number of square feet that an address is, and the number of stories that it is. If we looked at boundaries, we would give you the name of the school district you're in, or we might give the name of the neighborhood if you lived in a neighborhood name. When you're getting weather delivered and it kind of knows what your neighborhood is, that's our data that's driving that.
Wow. Okay. So that's a lot of good data, Pam. So we talked about text data. We talked about the type of data that Precisely has. What other types of data, do you see your clients looking to enrich their data with?
Yeah, demographics is often number one. That's a great place to start. We've done a lot with weather. Also done a lot with the property attributes. Property attributes is very helpful in a lot of different industries and different use cases, right? Understanding the age of a roof, not only for things like, if you think about P&C insurance claim, but banking and understanding when a homeowner might be kind of ready for a home improvement loan, right? So you can think about understanding, again, not just your history with the clients, but what could be driving their behavior right now, and what are they ready for right now? So those are probably the ones we use most common, as well as weather, if I hadn't said that.
Okay. Yeah, so with that, what benefits have you seen from data enrichment in these machine learning and predictive models?
Yeah, I have a couple of examples here actually that I pulled out. So two of these we did recently. So the one on the left here, we were building a utility damage prevention model. So this is when excavators need to dig at any site, they have to check in with the utility company, and they want to understand what is the risk that they're going to damage any utility assets. And if it's high, they want to send their people, their inspectors and auditors, to be on site. But those resources are expensive. They need to be careful where they use them and really make sure that they're going to the places that are of the highest risk. So we built a machine learning model to detect the likelihood of damage. And that alone was a good model we moved forward with. But we also brought in some external data, and what we found is that we were able to detect 25% more of those damages by adding in things like those property attributes, right? About the area and the square feet, and brought in things like traffic and boundaries to also marry the risk with the consequence. So what is the consequence of damage happening here? Is it right next to a school zone? Is it a high traffic area, right? So we really were able to improve the model itself and get better lift there. The one on the right, this was for an insurance company that wanted to understand when a claim comes in, is this going to be one that ends up with a very high loss ratio? Is it going to have total expenses over $500,000? Because sometimes those seem to come out of nowhere, and that seems to be happening more and more often with social inflation. And so they wanted to get a handle on that and have some early warning. So by adding some third-party data about the claimant and the area, we were able to detect 27% more of those claims that would end up being very high loss. And the interesting thing is that it's not just about that lift, right? The bottom line is how accurate is the model, and how is that going to help us detect these issues and these problems and stay ahead of them. But we're able to provide the actual features and data points that drive that model. So as Mike said, there can be like 9,000 data points. And there have been cases where we worked with Precisely and brought in hundreds of features to test out in the models. The ability to prioritize them and understand which ones are actually impactful in the model is very helpful, right? Because that can allow you to acquire less data, store, govern, manage less data, right? You can focus on what's actually going to help us get to this business outcome. And so we've been able to do that.
So that's the explainability part of it, right? That you're
exactly.
showing.
We want to be as transparent as possible, right? And that's another key feature.
Okay. Yeah. And okay. So yeah. And just for those of you out there, that may not be that familiar with machine learning and predictive analytics, we're talking about attributes and features, but basically a feature is an attribute. It may have more stuff associated with it. Would you say that you can take some attributes, like, where you're located or how long you've been a customer, create a ratio, maybe that's a feature, that then you're putting into the machine learning model. So when Pam was saying like 100 features, she was talking about, I guess you were talking about data that was, just available, data that you manipulated, to make a feature and so on. So
yeah, exactly. Features that, kind of that prepared data point that goes into that model, and we can extract those out of all kinds of raw data.
Right. And Mike, did you have anything you wanted to add to this question about the benefits that you've seen, maybe from your customers with data enrichment?
Yeah, just really doubling down on what Pam was saying, the insight that our customers are able to derive, it improves the integrity of their decision making. And that means that they're able to deliver a better customer experience. And it all comes down to that. And that's very frequently the conversations that we're having collectively with our customers, is how can they improve their customer experience? Well, they improve that through their decision making. How can they? And ultimately, it comes down to data integrity, the integrity of the data processing that we do on their data, plus the data enrichment capability, then the quality of the model that goes on top of that.
Yeah, the garbage in, garbage out thing definitely applies
Absolutely.
here. I remember when we were writing that Big Data for Dummies book, when the whole big data notion was just starting, and people thought, well, great, now that I have so much data, I don't really have to worry about, the quality of the data, because there's so much of it, it's just going to sort of even itself out in some way, shape, or form. It's like, no, that's not the case. Yeah, so pretty interesting. But, we've certainly heard at TDWI, we've certainly heard a lot of challenges that organizations have in terms of bringing data in for analysis. And one of the top ones, is data quality, I'll have to say. Mike, so sticking with you, it includes things like data quality, and then, integrating the data and keeping the data up to date. And then there's other issues. So what are the challenges with data enrichment and bringing in external data in for analytics? What do you see with your clients? What are some of their challenges?
Yeah, I mean, this is one of their key challenges, because it's such a big job, especially when you start looking at location data, which of course is where things are happening and so important. There are multiple techniques that we use, but I want to zero in on what is by far and away the most impactful capability that we've got. What we do is we use a unique identifier on addresses. So when I said right at the beginning that I was the addressing guy, what we do is when we process all addresses, we put a unique and persistent identifier. So unique meaning that it's a globally unique ID. There's nothing else that uses that identifier. And persistent meaning that from version to version of the product, the identifier stays the same. But also as addresses change, we keep the identifier the same. And I say as addresses change because addresses do change. Now, we process our customers' transactional data with our software that appends this unique identifier. Then what we've done is we've taken our data portfolio and we've appended our unique identifier to that data portfolio. And that makes it so that instead of being a complex join, and what I'll say is that frequently our clients think of this as an insurmountable mountain to get over, because it's truly momentous to think about the number of different things you need to do to join, particularly spatial or location-centric data with transaction data. It might be something as simple as performing a point in polygon type of application, but when you get polygons in polygons and overlapping polygons and distance calculations and measurements and routing requests, it's really very integrated and complex. Because we've got the technologies in-house that we actually sell to our clients, from a software perspective, we're able to apply that to our own data portfolio, use that on our data portfolio to append our unique identifier, and then we make it so that, quite frankly, it's a simple, stupid lookup between our customer's transaction data, our data portfolio, to create the enriched product at the end. And so we talk about this in terms of address data science. So one of the key things that makes this work, yes, it's the unique identifier. And we call that the precisely ID, which is this thing on the right-hand side. But if I just take you through this diagram for a second, our customers' data, well, they've got their own identifiers, their customer name, You see the top one at the top, VisionWorks, which happens to be at a mall. And this is real data. You know, they had this as Melissa Valley Mall in 88011. Well, that's not an address. Our software will interpret that address and give it its real street address. So we're able to transform that from Melissa Valley Mall into 700 South Telsa Boulevard in New Mexico, and then we append a unique ID to it. And so part of the keys to success in the address data science world is that ability to match the crazy stuff that people store in their reference data and in their transactional data, particularly around addressing, which is always in different formats, and being able to interpret it in volume, at speed, with a great deal of accuracy and consistency. And so then what we do is we then use that ID that we append, we call it the precise ID, as I said to you before, and we use that to add the context, so to do that enrichment process.
That makes sense, and that also helps with the quality of the data as well, right?
Certainly does. Yep, absolutely does.
So that's great. Pam, did you have anything you wanted to add about the challenges that organizations may face when they're bringing in data and what they're doing about it?
Yeah, just to reiterate that, it can be very challenging, right, to bring it in and connect everything in the right way and make it really usable. And again, that's where Precisely has been a great partner, because the tools that they have make this a lot easier, and they make it more trustworthy thanks to this Precisely key and matching. And, you know, this is an area that Ironside has capability in. So we've partnered up quite a bit where our team can go in and use those tools and bring in this data and enrich it, and my team can perform some predictive analytics on it. So it can be a big hurdle, and I feel like Precisely has really made that a lot easier to get past.
And
one thing I would just, sorry, Fern, one thing I'd just add as well is that many of the clients that we've got will take this ID structure and apply it to the reference data that they're buying, the enrichment data that they're buying from other third parties, not just us, and append this ID to it, and indeed into their own internal reference data that they produce, because a number of clients actually are producing their own data products, and they apply this to their products as well.
Okay, and then that goes into their data warehouse or data lake or whatever.
Absolutely, yeah.
Okay, yeah, that's what I was going to ask about with the with other types of data do. So Pam, let me ask you this question. You know, at TDWI, we always say, you know, it's really important to know the business problem that you're trying to solve, you know, when you're embarking upon analytics like machine learning or predictive analytics. So, you know, are there specific use cases that you've seen organizations start with in terms of data science and enriching their data? And what factors should they be thinking about?
This is a really critical question, and it's kind of surprising sometimes that when you think about machine learning and AI, sometimes the hardest thing is not the technical pieces. It can be, where do we start? Because I've seen a lot of organizations, they look at their data and they say, okay, we have to do AI. What can we solve with this? What use cases can we perform with the data we have? And they start with the data at this low level, and they may end up solving the wrong problem, a problem that nobody really has the need for. They go back to the business, and the business says, you didn't involve me. I don't know what this is. I'm not going to adopt it. And that has a lasting effect. I've seen organizations say, you know, we tried that a while ago. It didn't work. That predictive analytics machine learning is not for us, right? Because they solved the wrong problem. And so if you remember the progression of steps that we go through with data science as a service, one of those that some of our clients start with is a use case discovery, where we can interview business leaders from across the organization in different functional areas. And really we ask questions like, you know, what are your business needs right now? What are your goals? What are your challenges and pain points? What are the activities and decisions that get you to those goals? And then what's the information you need to make those decisions? And you can get all the way down to the data eventually. But what you do is you start with the business problem. It's led by the business, it's led by the leaders, and it's a way for them to get educated on AI too, and to get on board with it. And ultimately, what we want to do is that simultaneously look at the data. Do you have data that's accessible? Do you have unstructured data? Do you have, a whole bunch of different sources that need to be brought in? Is the data sitting in PDF somewhere that needs to be scraped out? But what are the data sources that would be needed for each of these use cases? And ultimately, if you think of this, pre-COVID, a big whiteboard, everybody has a sticky note with use cases, and we can plot them on business value and data viability. And you can see your priorities. These, you're not just going for low-hanging fruit. You're going for business value, and the data's there and it's ready, and we can act on it. And you move forward to pilots or those rapid viability assessments that I talked about. You also can identify those value traps. Those are the things that you might say, hey, we have the data, we can go solve this problem. But it's really not, solving any big burning business need at the time. And the other important piece is that data remediation, right? These are really important to the business, but either we don't have enough data, and maybe that's where we need to bring in some external data. Maybe we need to look at our data governance and our data collection and change things up, right? So there's some data remediation, there's activity you can do so that in 6 months, 12 months, whatever, of collecting data or governing it better, you can then go back to those and start building those models. So this gives a roadmap and a catalog that's prioritized in a way to get started. So we highly recommend taking some time to do this if an organization is really looking to move forward with AI, rather than just say, hey, we've got this data, let's go solve a problem, without really engaging with the business and thinking about the value that it's going to bring.
Yeah, that makes a lot of sense. And then helping them to sort of structure even how they would think about modeling the question, because I've seen like a lot of organizations, they're used to being reactive, they're not used to being proactive, so they're not necessarily thinking about the question that they want to ask in a proactive type of way, so to help them articulate that so that they can get used to that thought process. Also,
yeah,
I think
a business leader.
Really important.
Yeah, sorry. Just to add that a business leader doesn't need to know what machine learning is and what exactly a machine learning use case is, right? It's a discussion about what are their challenges and goals. And we can help to define that use case and walk you through those steps of those decision points, actions, and information you need. And so I think that it has this secondary value of driving AI adoption and a culture of AI adoption as well, because you get the business leaders involved. They start to understand this. They understand how would I actually use this machine learning output to solve these problems? And it really helps to get an organization kind of on the right path towards AI adoption.
Yeah, that makes sense. We see like a virtuous circle, where you do one, it's successful, the leaders are behind it, it just starts to build on itself. So, Mike, did you have anything you wanted to add, in terms of, what organizations should be thinking about in terms of getting started?
Well, I would say this, but I mean, the clear place for me to get started is right down at the core of their data production. It's going to be in fixing the quality, making sure the integrity on the data is absolutely right, because from our experience, and I think we've reiterated this multiple times, though, it is projects fail when we perform ML on garbage. So,
okay. I want to leave time. I want to leave time for audience questions, but I want to get to this last question here that I'd start with Mike with. We talked about getting started, but what are some of the barriers to actually getting started at TDWI? Or I can start with Pam first on this one. We typically see, things like, skills, culture, data integration. Those are what people oftentimes cite as, big barriers to getting started with AI. But what are you seeing in your practice?
Yeah, I can jump into this first. I often cite this O'Reilly survey because they ask this question every year, and these same 5 things always come to the top, and it resonates very well, Fern, with what you just said. I always am interested that, again, the top 2 are not technical things. It's understanding a need for AI and understanding the right use case to get started on. Those are the 2 top barriers to getting started, right? And so that's why that use case discovery process is so important. It helps you understand the use cases, and it gets everybody on the same page, and it gets the business leaders understanding the culture and the reason for AI and that value. But then, yeah, lack of skilled people, some data quality issues, or lack of sufficient data, and then the technology and infrastructure. And so these barriers to getting started in AI and to progressing further are really why we built that data science as a service Ascend AI solution, right? Because it hurdles you past all this. You don't need to have infrastructure. We have infrastructure, right? And we chose cutting edge infrastructure that is also pay as you go and scalable. And we have a data science team, and not just the data scientists, right? But the supporting pieces that data scientists need, the data engineers, the MLOps, solution architects, experienced users. So again, don't jump into getting a whole team when you can have this lease option and just hurdle past all of these. And that these barriers are really why we built that, and have had success with a lot of clients now getting past them and getting started much faster.
Yeah, that makes sense. I'm wondering, at TDWI, we often see that organizations getting started with data science, one of their strategies, they may bring in a few data scientists, but one of their strategies is that they say they want to upskill the business analysts to become data scientists. So with your customers, are there business analysts that you're working with that have sort of been targeted to, maybe ultimately go into this role?
Yeah, I see that a lot, and we often do work in kind of that mentor role, especially if they're building their own kind of center of excellence internally. And so we can work with them to get started and help in that mentorship and training up of a data scientist or a citizen data scientist from an analyst, right? But we also come into organizations that are a little more mature and do have a data science team, but some of their challenges are maybe they hired a bunch of academics, and I'm an academic and PhD, so I understand, very smart, they can build machine learning models, but these organizations have said we struggle to scale, we struggle to get it out to the business, and that's because academics build great machine learning models, but they're not business users, and they're also not engineers, right? And that production piece is a challenge. And I've had people hire really smart, technically savvy people who, they say, okay, we hired a data scientist, but after a while they left, they didn't have enough work to do. And the problem is that data scientist come in as a technician and expects you to tell them what use cases, and you kind of expect them to know what to do. And the reality is, a more seasoned data scientist or business leader with that expertise understands that transition. What are the right use cases for data science? And this is why I say data science is a team sport, right? You can't just bring in a technician or an academic or an engineer. It's really this breadth of skills. And that's why it's really hard for an organization getting started in AI to just hire their first data scientist and then go. And again, I think that's why data science as a service is valuable, because you've got that whole team and everyone aligned that you need without having to pay the capital expenses of a whole expansive team.
Yeah, that makes a lot of sense. Mike, did you have anything that you wanted to add about overcoming the challenges of getting started with AI?
I would just endorse what Pam just said about the team sport side of it. So where we see it being a success is where a data science team gets put in place, and they're focused and dedicated on, as she said, not both simultaneously the business side to achieve the outcomes that the business requires, and the technology side to achieve the how we're going to do it side. And that's so important to have that, because it's so rare to get an individual that can divide their brain and put it into both camps simultaneously. Right,
the unicorn, whatever.
Yeah.
All right, as I said, I want to leave time for audience questions. So thank you very much for participating in this roundtable. I'm going to turn it back over to Jim for audience Q&A.
Thanks, Fern. Our first question is for both Pam and Mike. You've talked a lot of ideas in the last half hour or so. If there's one key takeaway you'd like the audience to remember from this presentation, what would it be? Pam, let's start with you.
Well, just one is tough, but really I think that getting started is very challenging. And if any organization is looking to just get started and get over those hurdles, I think data science as a service is a fantastic option for that, of course. And also, as I said, is this vehicle for data enrichment without having to be intrusive to your current infrastructure, right? We evaluate the data right there. Know, is it going to be valuable? How valuable, right? Quantify that ROI and know exactly which data is going to be valuable. Yeah, and that precisely has just been a fantastic partner in this. They provide data integrity tools that help with that very challenging data integration piece. And so we work very well together with that, that process.
Mike, what's your one key takeaway?
I would say that data enrichment is a hard-learned skill, and that we precisely have come up with our methodology for doing it. I would say that never underestimate how hard that is. Ironside are expert at it. We are expert at it. And we find most people want to go do it themselves. And then they call us afterwards.
Our next question is for both of you as well, but Pam, I'll start again with you. You mentioned a little bit about working together. Why do Ironside and Precisely partner with each other? What's the relationship there?
For us, it's a few things that I've already mentioned, you know, knowing that they have this data integrity, that they have the Precisely key that we can count on being able to pair data up more easily, the tools to do that. But also, you know, this is kind of a one-stop data shop, you know, with that expansive set. So anytime I'm working on any use case, I'm always thinking through what's other data that we could bring in to help enhance this. I can look at their catalog and go through and pick things out and very easily bring that into the environment where I'm building machine learning models for my client and test it out, right? So it's a smooth process. It's a lot of available data to choose from. I can look at it, bring it in, and tell the client, you know, here's some external data we brought in, and here's exactly how much lift it's going to give you. So I think we've created that great process together.
Mike, your thoughts?
Yeah. My thoughts on it are very simple. I mean, Ironside has proven themselves to be so competent and capable in this space. We make good bedfellows in that respect, in that we don't, we're not trying to do each other's job. We're not trying to do each other's role. Here in our clients, we're working collaboratively together. There's great synergies between our products and their skills. So it's been a very valuable and open relationship for us to promote each other.
Mike, sticking with you, here's our next question. How did you implement Precisely ID?
Well, obviously, that's our Coca-Cola recipe. As to the details on how we do it, because what typically happens is we get that question from most of our clients, those that have been working in the world of addressing for years. I remember one large telco that begins with V. I was talking to them, and they said, "How did you do this? We've spent 11 years trying to figure this out." We've been working in the world of addressing for close to 40 years in the US and 30 years globally. We've got some of the biggest brands in that industry in our portfolio, and we've consolidated a lot of intellectual property. The idea behind doing it is not new. The execution of it is where it all comes down, and quite simply, we just focus. What I will tell you is that we're now doing more. We're actually applying machine learning and AI technologies to the production of it, if nothing else, for validation and testing. But that in its own right has actually been harder to build than just doing it manually, because we have the brains already.
Our next question is for all three of you. If we upskill our employees to apply data science in our work process, what skill set do you recommend?
Oh, that's a great question. Fern, I'd love to hear your thoughts too. It's challenging because people come to data science with all different backgrounds, right? I come from academic, where I really studied the algorithms themselves, but was newer to languages like Python and picked that up along the road. So Python's probably the #1 data science language to learn. Other people come from more of an engineering technical background, and they're excellent hackers and programmers, but they really need to understand the machine learning piece of it. All of that, though, just gets you to being able to build these models. It doesn't really get you to the point, as you would expand even further, to understanding the business, understanding how you would deploy something, how would you put it into production and test it, how do you get it to end users and get it to them in a way that they're going to adopt it and put it into practice. And so there are those technical skills like Python, studying machine learning algorithms that are out there, studying the open source libraries and knowing what's available, data visualization. But I think there's more to it than that, right? Once you have that foundation, it's thinking about it from a business perspective and thinking about it from a deployment and engineering and management perspective.
I would completely agree. I think you're spot on there. And what we saw at TDWI is we've seen that organizations, they may actually start to build models, and they may build a couple of them, but then they haven't thought about deploying them, or maybe they sort of get away with deploying one of them, but, and then they realize they need to scale it, and they don't have an ML ops team to do that. They don't have data engineers. They're asking their data scientists to do the data engineering work. So they're not necessarily thinking through sort of the whole end-to-end process. And they'll come and they'll say, oh boy, like we thought so much about building, we didn't think about deployment, and now we really need to think about deployment. And you can get away with that up to a certain point, but if you want to get value out of the model, you want to deploy it into production. So, that's definitely one of the issues. And then thinking sometimes, with some of the auto ML tools that are out there, that, well, we can just use those, and our business analysts can just use those tools, and, they'll presto become data scientists, which is not at all the case. They can help with a lot of the mundane tasks, sometimes, but I still say, you need to understand the algorithms. You need to be able to defend the output, interpret the output, all of that stuff. So there's a lot to know there.
I agree wholeheartedly. You can go very wrong very quickly if you don't know what you're doing with the automated tools.
Yeah, and I think that just one additional thing is really to focus on the business side of it, as we said about the team sport, Pam. Unless we've got someone that can really be liaising with the with the C-level executives to understand what outcomes we are seeking as a team in our own right, and being able to go through and being able to work with the team to translate that to ultimately into the model. That's critical, because I can't even imagine how many times some amazing work has been done that's produced no real benefit or has not been able to be deployed simply because it missed the mark by a couple of degrees.
Yeah. Models are only costing you money until they're in production, right? Getting to the business, and that's when they're going to save you money, make you money.
Yeah.
Pam, our last question is, I know you talked about your clients wanting additional data. The question is, how much data is needed for machine learning? Is there some rule of thumb for that?
There's really not. I get this question a lot, and it feels like there should be some answer, some number, some, X terabytes or something like that. And it's not, and it depends on the use case. For example, if you're trying to predict something that occurs 50% of the time and it doesn't occur 50% of the time, you actually can get away with less data. But think about trying to predict something like utility damage that happens 0.05% of the time or something, some very small number. You need a lot more data points and examples so that the model can pick up when it actually does happen. And so there's nuances like that that just impact that number and how do you detect it. I will say, however, that you can get a lot of value out of small data. I have clients that have, a couple hundred clients or customers, and we've run advanced analytics on them and made them valuable. As long as you understand the algorithms and you understand the limitations of that small data, you can actually do some very powerful things. So you just have to know the distributions with them and what the restrictions of your algorithms are. So I'm certainly not afraid of small data.
Well, we've reached the end of our hour, so let me take a moment to thank our speakers today. We heard from Fern Halper with TDWI, Pam Askar with the Ironside Group, and Mike Ashmore with Precisely. And again, thanks to Ironside and Precisely for sponsoring today's webinar. Remember that we've recorded and we will be emailing you a link to an archived version of the presentation. Feel free to share that with colleagues. And don't forget, if you'd like a copy of today's presentation, use the click here for a PDF line. Finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, webinars, and information about business intelligence, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. So let's here today. Let me say thank you very much for attending. This concludes today's event.
Thank you very much.